So today we're going to use or learn a different way to solve systems of equations. Yesterday we were graphing and we saw where they crossed. Do you remember doing that?
No.
That's not always the most appropriate way to do it, so there are other options. And Blair, I know you don't know because you weren't here, but we'll see. We'll go over that. Okay, so before we graph the other way, because it's very algebraic, I want to review some solving equations, and we're going to be going through two different types. One where you have variables on both sides, and one where you have to distribute as part of your solving. So those are the things that we're going to review first. Does anybody remember how to solve an equation with variables on both sides? Yeah. Yep, get all the variables on one side, all the non-variable things on the other side. It really doesn't matter which way you go. It doesn't matter if you move all the variables to the right or all the variables to the left. It makes no difference whatsoever. It's just whatever kind of happens. Some people follow a specific way. I typically move the variable that is the smallest. So for me, negative 3n is smaller than 7n. So I'm going to start by adding 3n over to 7n. The reason I add is because it's minus, and on the left it'll cancel, and on the right I can combine those together. Then I'll bring everything else down. That's a positive 10n, so it's plus, the equal sign comes down, and then that 15 hanging out over there on the other side also comes down. So then next, I have to get all the non-variable things on one side. So that leaves me with this 5 to remove. Get rid of it on both sides. And then lastly, I can solve for n. How do I figure out what n is? Divide by 10. Beautiful. Some of you guys are great at this. So n is what? 1. Beautiful. All right, let's do that again. I could either add 4p or add 1p. Anybody have a thought? Add 4p. Remember, this is minus or negative 1p. So what is negative 1 plus 4? 3. Bring down the minus 8. Bring down the negative 2. What's my next move? Add 8. How do I finish this off? Divide by 3. What's my final answer for p? Perfect. Okay, that's with variables on both sides. If I have a problem where I need to distribute, oops, I'm trying to get that to come in clear. Okay, if I have a problem I need to distribute, I follow it a little bit a different way, but I'm still going to follow the solving rules. So I'm going to start by distributing. Do you guys remember the distributive property? Where you multiply whatever's on the outside of the parentheses through to everything on the inside. So this is 6 times 8. And 6 times 6. And then everything else comes down. Once I distribute, I can combine the p's, and I heard add the 2 p's. I can combine those together. That's 41p plus 48 equals 171. Now I'm in a position where I can just solve a two-step equation just like normal. Get rid of the 48. Sometimes I need a calculator to help me. It doesn't make me weak. I don't know. I was just maybe feeling like maybe I looked weak. So I just plug that in and I get 123. I ran out of room. Finish off strong by dividing. So I already got 123 in there. I'm going to divide by 41. 3 is my answer. Good? Feeling it? Don't forget that if there are negatives, you have to keep those in mind as well. So when I distribute that 4 as in negative 4. So negative 4 times 4 is negative 16. Negative 4 times negative 8 is positive 32m. Bring everything else down. Now here's where people get a little bit bothered. Do I do 5m plus 32 or 5m minus 32? How many say minus? How many say plus? Okay. Always go with the sign in front. So this is 5m plus 32. The minus goes with the 16. But it goes with the 16, not with the 32. So that's 37m minus 16 equals 243. And now again, I can finish solving like I've done in the past. Add the 16. And divide by the 37. Again, I just plug it in my calculator. I get 7. Okay? So we're going to be doing solving of equations similar to the 4 that we just did. That's why I just kind of wanted to refresh our brains on that. You can look back at those. Does anybody have a question about anything that we just did before we begin? All right. Then, let's review yesterday. What did one solution look like when we were done? It was like, yeah, intersecting lines, right? And we had an x value and a y value. Ring a bell? What did no solution look like? Parallel lines. Okay, today, no solution, when you're done, will look like this. You'll get some number like 5 equals 18. Will 5 ever equal 18? No. You'll get something that will never happen. It is a false statement. Now, it's not restricted to 5 equals 18. It could be 10 equals 3, or negative 7 equals 1, or 0 equals 25. But it's going to be something that is false. And when it's false, you have no solution. When it's one solution, you will get an x value and you will get a y value. Or if the variables change, it could be different letters as well. Lastly, many solutions. Does anybody remember what that one looked like? Yeah. Yep, it was one line on top of the other. Oops. So it would be one line on top of the other, 2 lines that were the same. Today, it's going to look like this. 4 equals 4. It is something that is always true. It will always happen that way. 4 is always 4. But again, it's not restricted to 4 equals 4. It could be 10 equals 10, or 100 equals 100, or 20 equals 20. Negative 3 equals negative 3. It's something that is always true. It is a true statement. So no solutions comes up as a false statement. Many solutions comes up as a true statement. One solution will just come up as answers. So let's get moving. We're going to be using substitution. Now, why would substitution be a method to solve when we could just go ahead and graph this? One of the big reasons where substitution is much more handy is if A, the numbers are a little bit big, like this y-intercept is going to be off of the graphs that we usually have, or B, we don't have a graph, or C, maybe it doesn't cross at a nice point. All of our graphs crossed at nice points. But here's how substitution works. I've got both of these y's. If these are both y, and they're supposed to both be the same y, then they must be equal to each other. So if y is 3x minus 10, and y is also 4x minus 13, then 3x minus 10 must equal 4x minus 13. Now I've just set up one equation with one variable that I solve. So remember when we were doing these variables on both sides, what do? Get all variables on one side, all non-variables on the other. So let's start. Minus 3x, minus 3x. Add 13, add 13. This one was nice because I came down to 1x, so I don't have to do any dividing. That means x is 3. Remember, this is something that can be true. So that means this must be a one solution situation. I just need the y part of it. I got the x, now I need the y. The x is 3. What's y? Well, I can figure that out by plugging the 3 into one of these equations. It doesn't matter which one. So y equals 3 times 3 minus 10, which is 9 minus 10, or negative 1. So then I go back down here, add my answer. That means if I were to graph these two, they would have crossed at the point 3, negative 1. Lot of algebra today. All right? 2 y's equaling 2 different things. Therefore, the 2 different things must equal each other. Now I want to get all the variables on one side, all the non-variables on the other side. I usually, like I said earlier, I don't know if you remember me saying this, but I usually get rid of the smaller variable. It's not a rule, it's just what I do. So this time I'm going to remove the 7x. What's it? Yeah, you need to start joining us. Yeah. It does. Yeah. I do. Yeah, I get it. Go ahead. I'm for real. No, I get it. It's hard to concentrate sometimes. Okay, so I got my x. Now I need the y. How do I do y? I did the math, I did the algebra, I got my x. How can I do y? How can I figure out what y is? How do I do y? Put the x in for either one of these. So I'll do the top one. No reason why I chose the top. Y equals 7 times negative 4 plus 24, which is negative 28 plus 24, which is Negative 4. So far I've gotten one solution for both of those. Let's check another one. This one looks a little different, number 7, doesn't it? In fact, it's easier because I have two y's that equal two different things. Therefore, those two different things must equal each other. Well, the second one doesn't have an x in it, which means that I'm not going to have a variable on both sides, which means that I can just solve this right away like I normally solve a value or an equation. So I added 7 on both sides. I got 2x equals 4. I divided by 2 on both sides. I got x equals 2. Now I could plug the 2 back in this top one, but they already told me what y is. What's y? Yeah. So I can just write my point like that. Those types of problems are easier to do. Okay? So here's where our trouble is going to come in a little bit. What's wrong? Are we good? Okay, so here's where we run into another little problem. Here's another time where graphing is not going to be efficient. What if both of my equations are not in the easy form to graph? Then it's easier for me to do a different method. But I do need at least one variable by itself. Because if y equals x plus 6, then I can replace y up here with x plus 6. So that x plus 6 right here, that y equals, is going to go into the upper equation for y. So this becomes the opposite of x minus 6, not times y, but times x plus 6 equals negative 22. So I just took the x plus 6 that the y equals and put that in for y. Now we have a problem like we did in the 3 and 4 when we just started class. So I distribute. I combine like terms. What's the number in front of this x if I don't see it? Yep, so negative 1. What's negative 1 minus 6? How do I solve?
That's fake. So fake. You're so dumb.
So I have my x. Now I need to go back up here and find my y. I always put it in the easier of the two equations. And that second one is the easier equation. So y equals negative 2 plus 6, or 4. So 4 is my answer. Oops, I should have made that visible for you. So 4 is my answer. Again, it doesn't matter which equation I use. I always use the easiest one. And the easiest one for me here was the bottom one. When we're doing problems like the previous ones, it doesn't matter what you use. All right, get that down, and then we'll move on to the next. Anybody have any questions so far? Am I ready to move on to 9? Okay, here we go. What do I do with 6x plus 4?
You bring the 4 to the y, and you 3y, right?
I bring the 6x plus 4 in for that y in the negative 3y, yep. So 18x minus 3 times, not y, but 6x plus 4 equals negative 2. And then I distribute. And then I combine like terms. What's another way to write 0x? What's 0 times anything?
0.
Yeah, this would be 0 minus 12 equals negative 2. What's 0 minus 12? What happened here? This is never true. Always false. Never going to happen. Negative 12 will never equal negative 2. I'm done with that problem. All right? What do I do for the next one? What goes in that opening? Nice. Because that was what y equaled, so I substituted that in for y. Distribute. And solve. Help me solve. Yep, x equals negative 2. Let's put negative 2 back up in the easy one. So that means y equals 2 times negative 2 plus 1. That's negative 4 plus 1. What's negative 4 plus 1? Negative 3. So negative 3 is my answer. All right, so now, next, I'm going to let you guys try these next two. I don't care if you graph to solve or if you use substitution to solve, but I'm going to give you a few moments to try and then we'll take a look at your answers. I chose to graph the first one because of that fraction. So I started by going up 2 and then down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2. Oops, it's still unfrozen, so you guys can't see. But here we go. Trying again. Graphed the first one because the fraction. There we go. And I found that they crossed at negative 2, 3. How many people got that as an answer? Negative 2, 3. Okay. The next one I chose not to graph because I didn't like that steep slope, so I just set them equal to each other, and I ended up with a no solution. Did anybody get both of those correct? Good, good. Okay. So I'm going to hand out your homework.